Good afternoon. My name is Dennis, and I work for ARM and focus on the enterprise system software ecosystem. This is my today's topic, how deployment of Ceph cluster with Rook on top of Kubernetes. Maybe you know the Rook is open source project hosted by CNCF to orchestrate the distributed storage system with Kubernetes primitives. So in this presentation, I will give an introduction of the Rook project and how to deploy the Ceph cluster with the Rook. So this is today's agenda. First, we will give an overview of the design of the Rook project and how it works and what the Rook is. After that, we will talk about the three key elements of the Rook project, namely the operate, agent, and discover pods. After that, we will talk about how to use Rook to deploy a Ceph cluster on top of Kubernetes automatically. Additionally, when we deploy a Ceph cluster with Rook, and we will give an introduction of the flex volume driver, because if we have a basic understanding of the flex volume driver, we will have a better understanding of the following content. For example, the volume operations such as the storage provisioning and consuming. At last, I will give a status update of the Rook projects on ARM platform. So this is an overview of the design of Rook project. The Rook project is on top of the Kubernetes cluster. So first, we need to set up a Kubernetes cluster. And in this diagram, we can see that the Kubernetes cluster is composed of several nodes. Nodes 0, nodes 1, node 2. For the node 0, it has no any difference with other nodes from the perspective of Kubernetes. So we will zoom into this node to see what's the magic of the Rook projects. Inside the node 0, we can see that there are Rook operate and Rook agent pods. Actually, there is a Rook discover pod, but we don't show in this node. But you can see that the discover pods in other nodes, for example, the node 1, 2, or other nodes. The Rook operate is created by the Kubernetes utility. It's not. It's the mechanism of Kubernetes, not the Rooks. And the responsibility of the Rook operator is to spawn the other Rook pods, such as the Rook agent and discover pods. If we zoom into the node 0, we can see that the Rook agent and the Rook and Kubernetes, there is a flex volume plugin in the Kubernetes. Also, we have a Rook flex volume driver from the Rook running in the Rook agent pods. So this is a out-of-tree flex volume mechanism. Out-of-tree means that the third-party storage vendor can develop their own plugin and don't depend on the Kubernetes code base. So the flex volume driver communicated with the flex volume plugin of the Kubernetes through the UDS. UDS means the Unix domain socket. So Rook, now Rook is based on the flex volume. It doesn't support the CSR yet. CSR is a container storage interface. For the Ceph cluster, Rook doesn't change the data plane of the Ceph cluster. It just changes the control plane of the Ceph. So this is the operate pods. Operate pods is a simple container function at the cluster level. The responsibility of the operate pods is to bootstrap and monitor the storage cluster. Bootstrap means it will spawn the agent and discover pod. Monitor means that it will watch the resource changes in the cluster. We can use the command line, such as the copy control create operator to create the Rook operate pod. So that means the Rook operate POD is created by the Kubernetes mechanism. It's not the Rook's. And Rook operate POD is created through the Kubernetes deployment object with a replica set. The replica set to 1, that means there is only one Rook operate pods running in the cluster. The argument to set up the operate POD container is Ceph operate, which will trigger the /use local bin /rook Ceph operate command line inside the container. This is the mechanism of the SPF 13 Cobra projects. So the start operator will be invoked to bootstrap the agent and the discover pod in form of the daemon set. Daemon set means that the Rook agent and the discover pods will run running in every node in the cluster. So this is operate pods. This slide will show the workflow of the operate pods. We can see that from the start operate function, it will create the agent daemon set. So for the every node in the cluster, the create agent daemon set will spawn the agent agent pods in every node, just like this. And the main workflow of the operate continue to forward like this. Now it creates the discover a daemon set. Just like the agent, it will create the discover pods in every node in the cluster, like this. So it's a parallel process. That means the workflow of the operate will be continued, and when the agent pod is start, it will execute other tasks at the same time. So for the operate workflow, the last step is to create the provisioning control and the cluster control. These two controls is very important for the Rook projects, because we will talk about it in the following slides. You will see that the provisioning control and the cluster control play a very important role to bootstrap the Rook and the Ceph cluster. And provisioning control will watch the storage resource change, such as add, delete, or update. So the two controls created by the operate pods will watch the resource changes in the cluster, such as the add, delete, or update resource. So we need to remember that one of the most important thing in this slide is that the operate include provisioning control. Provisioning control will watch the storage resource change in the Ceph cluster. For example, it will take the responsibility to do the storage provisioning. We will have more details about this process in the following slides. So now we talk about the agent and the discover pods of the Rook. Discover is used to detect the available devices in the node periodically. It's not very important. So in today's presentation, we will not talk more about it. So all the rest of content in these slides is about the agent. So agent is you can regard the agent pod as a mini operate that functions at the node level. Just as I mentioned, that the agent pod is created in form of daemon set. That means every node will run agent pod. Agent pod set up with the arguments is Ceph agent. So just as we mentioned that with the individual project SP13 Cobra projects, we will call the start agent when we are running the pods, when we're running the agent pod inside the node. So the responsibility of the Rook agent pods is to install the Rook flex volume driver to the volume plugin directory. This directory is specified by the flex volume spec. Also, of course, it can be configured by the end user. Another thing of the agent pod is to perform the storage operations on behalf of the flex volume driver, such as attach, detach, mount via the Unix domain socket. Let's take a look at the diagram in this slide. We can see that there is a kubelet. Kubelet is belong to the Kubernetes code. We can see that there is a flex volume plugin. It's from the it's belong to the code base of the Kubernetes, not the Rooks. And for the agent pod, we have a flex volume driver. This is belong to the Rook projects. And also we have a Rook flex volume driver. The one workload pod scheduled on a specific node, the Kubernetes will look up the flex volume driver, and then call the flex volume driver. Flex volume driver will interact with the flex volume server in the agent pods through the UDS. Ceph cluster deployment with Rook. We just mentioned that Rook has a cluster control that is used to watch the resource changes within the cluster. So when we use input the Kubernetes control create cluster YAML command line in the terminal, this will trigger the Ceph cluster bootstrap workflow. That means because we mentioned in the previous slide that the output has created a cluster control, which is watching the resource changes in the cluster. So if we create the cluster Kubernetes control, use the Kubernetes control to create the cluster, and it will trigger the resource change in the cluster. So the Rook output will configure the pod spec of the monitor and launch the pod with make deployment. That means the output is responsible for running the Ceph daemons inside the cluster. Also, it will launch the Ceph manager and the monitor daemon set with the similar methods. So finally, we will get the Ceph cluster like this. This is on a 2 nodes cluster. You can see that we have a manager pod, and also we have 3 monitors pods and 2 OSD pods. So after that, we have a Ceph cluster available now. The Ceph cluster is not deployed by manually. It's totally by the Rook source code. So this slide we will describe the flex volume driver, the Rook flex. Rook flex exists in form of a binary file, and has been deployed by the agent into the volume plugin. We have mentioned that in the previous slides. Deployed into the volume plugin is very simple. It's just copy the Rook flex volume driver into the specific directory in the hoster. The volume plugin directory is specified by the flex volume spec. Rook flex implement the mount and unmount method requested by the flex volume spec. Actually, there are two options for the implementation of the flex volume driver. But the Rook uses option 2. That means it just implement the mount and unmount method. The last item lists the storage-related YAML file, storage-related part of in the YAML file. We can see that it has two parts. One part is the storage provisioning, and another part is the storage consuming. The two parts is independent. We can write the two parts in two separate YAML file, but in reality, we combine the two parts into one YAML file of the workloads, specific workloads. For the storage provisioning part, we can see that we use the PVC, that means the persistent volume claim, and it will point storage class. And the storage consuming is for the specific workloads. Specific, the workloads will consuming the storage. So it will mount the, the workloads will require to mount the volume, the storage volume provided by the storage provisioning part to the workloads. For example, mount the block device into the ports to a specific directory, such as the /www/html. We will give more details how this happens in the following slides for the storage provisioning and the storage consuming. So this slide will give more details about the flex volume driver. For Rook, it's a rookflex. Rookflex is a binary file. And when the Kubernetes want to schedule a specific workload to a node, if the workloads want to consume storage, it will specify the storage in the YAML file. Just we see in the previous slide that in the storage consuming part, there is a volume and mount fields in the YAML file. Some workloads doesn't consume the storage, so maybe this workload doesn't need to such kind of YAML file. So let's see when the Kubernetes want to schedule a workload to a node, how the Kubernetes interact with the flex volume driver. The process is like this. Just we mentioned in the previous slides that these workloads will consume the storage, and it specifies the storage in the YAML file. So when the Kubernetes want to running the workload pods, it will find that there is a storage consuming requirement. So it will look up the right flex volume driver first. This lookup process can be found in the lookup process is implemented by the Kubernetes flex volume plugin. So that means the code belong to the Kubernetes, not the Rooks. So finally, the Kubernetes will find the right flex volume driver, and will call the mount method of the flex volume driver, just as the call the rookflex mount, because rookflex is a binary, just as a normal execution file. So the above amount will call the corresponding function in Rook agent via UDS. We will have a detailed diagram to demonstrate the process in the following slides. And the Rook agent will attach the volume into the node, because when the operator creates a volume in the cluster, the volume doesn't belong to any specific nodes. But the workloads is scheduled to maybe to a different node than the node that the operator is running. So let's see these slides will explaining the how the volume has been provided, and how the workloads consuming the these volumes. First, we will create a persistent volume claim. This is the command line. The command line will trigger will route to the operate, because just we mentioned in the previous slides that the operate has provisioning control. It watches the resource change in the Ceph cluster. So when we when we want to create a PVC, that means that there is a resource change in the cluster, and will be captured by the provisioning control of the operate. So the operate will do is to create a volume in the cluster, Ceph cluster, and bind to the PV object. But now the volume doesn't belong to any specific nodes. So the next step is, next part is the workload want to consume in the volume. So we use this command line to schedule the workload to nodes. The nodes may be not may be not in the same node as the operator running. So the Kubernetes will call the Rook flex volume driver, and the Rook flex volume driver call the flex volume server in the agent, and the agent will get the PV from the Ceph cluster, and after that, it will attach the volume to the node the workload is running. So attach means that it will create a block device like this. The block device generated after the block device generated, and it will mount to the workloads. It's belong to the Mobi or container technology. So we will don't have more details about this. And okay, so there are two parts. One part is the provisioning part. Another is attach and mount the block volume to the workloads. So the last is status update on ARM platform, and we take part in the Rook community activity. And now, so far, we have 14 patches have been merged into the upstream mainline code. And now Rook can be built and run smoothly on ARM platforms. And we have also two Rook-related submissions accepted by upcoming the Open Source Summit, EU and KubeCon held in Shanghai, November. And also in the future, we have a plan to support the CSI. So this is a presentation. Thank you for your time. Thanks.